There is a plant floating on the surface of a pond less than a mile from where you are sitting right now that contains more protein per gram than eggs. Not 10% more, not 20% more, 45% protein by dry weight. Eggs contain 13%. Chicken breast contains 23%. Soybeans, the so-called king of plant protein, contain 35%. This plant buries all of them. It doubles its own body mass in 16 hours. Not 16 days, not 16 weeks, 16 hours. It is the fastest growing flowering plant ever recorded on Earth. And in 2015, the Guinness Book of World Records certified it after a specimen called Clone 2005 achieved a biomass mass doubling time of 29.3 hours under controlled laboratory conditions. But under optimal field conditions, it moves even faster. It requires no soil, no fertilizer, no pesticide, no irrigation system, no farmland. It grows in a bucket of water on your back porch. It contains all 9 essential amino acids in ratios that match the exact profile recommended by the World Health Organization for Human Nutrition. It produces bioavailable vitamin B12, a nutrient the entire scientific establishment told you could only come from animals. It cleans the water it is rose in, pulling out up to 99% of nitrogen, phosphorus and heavy metals. And for over 2,000 years, civilizations on 4 continents ate it, healed with it and revered it as one of the most important plants in their food systems. Then the modern agricultural industry spent billions convincing the world it was nothing more than pond scum. What they did not tell you is that this single organism could replace the entire protein supplement industry overnight. This is duckweed, Wolffia globosa, the smallest flowering plant on Earth. And this is the story of how the most nutritious organism on the planet was deliberately erased from your plate. The people of northern Thailand have a name for it. They call it Kai Nam. It translates directly to eggs of the water. Not a metaphor, not a marketing slogan, a nutritional description passed down through centuries of observation. For generations, families in the river valleys of Thailand, Laos, Myanmar and Cambodia have harvested duckweed from still waterways every morning, the way Western cultures collect chicken eggs. They stir it into curries, they fold it into omelettes, they toss it raw into spicy salads and stir-fried dishes. In the markets of Chiang Mai and the Isan region, it sits on the vegetable tables between the morning glory and the holy basil, sold by the bag, eaten by the handful. The Thai government now classifies it as a key national bioresource, and in 2021 launched a 300 million yen joint research initiative with Japan under the SATREPS program to unlock its full agricultural and nutritional potential. Kasetsart University, Hokkaido University, Osaka University and Kyoto University are all collaborating on the project. This is not fringe science. This is national policy backed by 2 of the most technologically advanced nations on the planet. But the Thai were not the first to understand what this plant could do. The historical record stretches back over 2,000 years and spans civilizations that had no contact with one another. In ancient China, duckweed appeared in Han Dynasty medicinal texts as a treatment for high fever, its cooling properties documented in herbal formulas that endured 20 centuries of dynastic upheaval because they worked. Traditional Chinese practitioners prescribed it for inflammation, for skin conditions, for fever reduction, at a time when most of Europe had not yet developed a written pharmacopoeia. In India, Buddhist monks consumed duckweed as a symbol of asceticism and purity, a food so elemental it required nothing from the earth itself to grow, floating above the soil in a state the monks considered spiritually significant. Across the Pacific, the classical Maya civilization integrated duckweed into rituals and food systems in the swamplands of the Yucatan Peninsula. Researchers have identified what they call a potential case of ethnobotanical convergence between the Chinese Han and classical Maya cultures, 2 societies separated by an ocean and 3,000 miles who independently documented the same plant for the same fever-reducing purpose. The Roman physician Dioscorides catalogued it around 60 CE in his 5-volume treatise De Materia Medica, the foundational text of Western pharmacology for 1,500 years, prescribing it for inflammation and temperature-related illness. In Heian-era Japan, duckweed floated so persistently in flooded rice paddies that it entered the imperial poetry anthologies of the 9th and 10th centuries under the name Yukikusa, literally floating plant, becoming a cultural symbol of resilience and endurance. These were not isolated incidents of primitive people grasping at pond scum. These were sophisticated civilizations spanning the Americas, Europe, Asia, and the Near East, and separated by oceans and centuries, who independently arrived at the same conclusion. This plant was food, this plant was medicine, this plant was essential. Modern science did not just confirm what the ancients knew, it shattered every assumption about what a plant could be. In 2017, a team led by Professor Klaus J. Appenroth at the University of Jena in Germany published a comprehensive nutritional analysis of duckweed species across all 5 genera in the journal Food Chemistry. The results were extraordinary. Protein content ranged from 20 to 45% of dry weight, depending on the nitrogen content of the growing water. Amino acid distributions were so close to the World Health Organization reference protein for human nutrition that the researchers flagged duckweed as one of the most promising plant-based protein sources ever analysed. Lysine, often the limiting amino acid in plant proteins, measured 4.8%. Methionine plus cysteine reached 2.7%. Phenylalanine plus tyrosine hit 7.7%. Nearly every amino acid ratio met or exceeded World Health Organization benchmarks. Polyunsaturated fatty acid content exceeded 60% of total fat, with omega-3 levels higher than omega-6 in most species tested, producing an omega-6 to omega-3 ratio of 0.5 or less. To put that in context, the Western diet typically runs at a ratio of 15:1. Duckweed inverts it entirely. Its fatty acid profile rivals wild-caught salmon, and it does this in a plant that grows in a bucket of still water. But the study that changed the global conversation came from Ben-Gurion University of the Negev in Israel. In 2019, Professor Iris Shea and doctoral researcher Hilla Zelicha published a randomized crossover-controlled trial in diabetes care, the official journal of the American Diabetes Association. 20 abdominally obese participants with elevated fasting glucose replaced dinner with either a Mankai duckweed shake or a yogurt shake matched precisely for carbohydrates, protein, lipids, and calories. After 2 weeks of continuous glucose monitoring across 97 total observation days, the results were unambiguous. The duckweed group showed significantly lower postprandial glucose peaks, delayed peak time, faster return to baseline, and lower next morning fasting glucose levels. In 2024, a second randomized crossover trial at Sheba Medical Center confirmed what the first study suggested on a larger scale. 45 patients with type 2 diabetes consumed either a Mankai drink or water after dinner for 2 weeks, then switched. Duckweed reduced post-meal blood sugar by approximately 20%, lowered peak sugar levels, and accelerated return to baseline. The researchers stated plainly that the effect was comparable to some diabetes medications. The plant accomplished with a glass of green water what the pharmaceutical industry charges hundreds of dollars a month to achieve with synthetic compounds, and it did something else. Something no other plant on Earth has been proven to do at meaningful scale. It produced bioavailable vitamin B12, not a trace, not an inactive analogue, actual cobalamin that the human body can absorb and use, produced by bacteria living in symbiosis with the plant. For decades, the medical establishment told every vegan, every vegetarian, every person who questioned the necessity of animal products that vitamin B12 could only come from meat, dairy, or supplements manufactured in a factory. Duckweed broke that claim apart. Harvard apparently agreed. Mankai smoothies were introduced in the Harvard School of Public Health cafeteria. So why is the most protein-dense, fastest-growing, most nutritionally complete plant on the planet not in every grocery store on Earth? Why is it not in every school cafeteria, every hospital meal plan, every emergency food kit distributed to disaster zones where protein deficiency kills more children than the disaster itself? The answer requires no conspiracy theory. It requires only arithmetic. The global protein supplement industry generates $28 billion a year selling whey powders, soy isolates, and casein shakes in branded containers with patented formulas, influencer partnerships, and subscription models. That market is projected to exceed $50 billion by 2032. The soy industry alone occupies over 300 million acres of farmland worldwide, drives deforestation in the Amazon basin, requires billions of dollars in fertilizer inputs, and sustains an entire ecosystem of seed patents, chemical contracts and processing facilities. Every acre of soy grown is an acre that needs herbicides, pesticides, fungicides, harvesting equipment, drying facilities, and shipping infrastructure. Every step generates revenue for someone. Now consider duckweed. It cannot be patented. It grows wild on every continent except Antarctica. It does not need a factory. It does not need a supply chain. It does not need a celebrity spokesperson or a subscription model. A family can produce their entire daily protein requirement in a shallow plastic container on a balcony using 95% less water than traditional crops. That is not an innovation the protein industry can monetize. It is a threat they must neutralize. And they have powerful allies. The aquatic herbicide industry generates over $1 billion annually, selling chemical formulations specifically designed to eradicate duckweed from ponds, lakes, and waterways. Products with names like Sonar, Wipeout, Dequat, Knockdown Defense, and Clipper are marketed to homeowners, municipalities, golf courses, and agricultural operations as essential tools for controlling what they label an invasive nuisance. Fluoridone treatments run $750 to $1,000 per surface acre. Dequat applications cost $200 to $400 per acre. And because a single duckweed frond can produce over 17,000 offspring in just 2 weeks, the herbicide companies have engineered a perpetual revenue cycle. Kill the plant, watch it return, sell more chemicals. The US Army Corps of Engineers runs official aquatic herbicide trials. State university extension services publish eradication guides. Homeowner associations enforce clear water aesthetics that mandate chemical treatment of any green surface. The entire institutional infrastructure of Western water management treats the most nutritious plant on Earth the same way it treats crabgrass and poison ivy, as a nuisance to be destroyed at any cost. The terminology itself is a weapon. Call it a weed, and no one asks questions. Call it a superfood, and suddenly every herbicide company has a public relations catastrophe on its hands. The pattern is identical to what happened to amaranth, purslane, and lamb's quarters, plants that indigenous peoples cultivated for millennia before colonial agricultural systems reclassified them as weeds to protect cash crop monocultures. The economic logic is systemic. Industrial agriculture depends on dependency. Patented seeds, proprietary fertilizers, licensed pesticides, controlled distribution channels. Duckweed breaks every link in that chain. It needs no seed purchase because it reproduces asexually, budding a new daughter plant from every frond. It needs no fertilizer because it absorbs nitrogen and phosphorus directly from water. It needs no pesticide because it has shed the genes for pest defense entirely. In 2021, researchers at the Salk Institute sequenced the Wolffia genome and discovered the plant had eliminated root growth genes and defense mechanism genes altogether, channeling all its genetic resources into one function. Growth. The plant evolved to do exactly one thing at the molecular level: produce protein as fast as biologically possible. And the industries that profit from selling protein do not want you to know it exists. But duckweed refuses to disappear. It cannot be eradicated because it was never meant to be controlled. It was meant to feed. NASA tested it aboard the International Space Station in 2023 after SpaceX delivered specimens to orbit, and engineers calculated that a compact vertical duckweed farm could sustain astronauts on a 3-year Mars mission. The logic was simple. The plant produces the highest protein yield per unit of water of any known crop, needs no soil, needs no gravity-dependent root system, and its growth water can be recycled indefinitely. At NASA's own National Space Technology Laboratories, duckweed-based phytoremediation systems have treated over 750 cubic meters of wastewater daily, outperforming conventional chemical treatment and recovering biomass for biofuel production simultaneously. A Jacobs Innovation Grant demonstrated that a single species of duckweed mitigated 97% of biofilm in spacecraft wastewater systems. The European Union and the United States have begun approving duckweed species as novel foods for human consumption, a regulatory shift that signals the wall of institutional resistance is cracking. In Thailand, the company Wolffia operates commercial aquaculture facilities growing Wolffia globosa for grocery store shelves across the country. In Israel, clinical researchers continue publishing trial after trial, documenting its capacity to manage blood sugar, reduce liver fat, improve vascular health, and reshape the gut microbiome. A 300 million yen international research consortium spanning 8 universities is mapping its genome and optimizing its protein yield for mass cultivation. The knowledge never vanished. It was pushed to the margins by industries that could not profit from it. But it survived in the places where profit was never the point. In the paddy fields of Heian-era Japan, in the curry pots of northern Thailand, in the swamp gardens of the Yucatan, in the clinical laboratories of Ben-Gurion University, and now in the space stations orbiting 250 miles above the Earth. You can grow it yourself. A shallow container no larger than a baking pan. Still water, sunlight. A starter culture that costs less than a single serving of the protein powder sitting in your kitchen cabinet right now. Within 1 week, you will have a self-replenishing protein source that doubles daily. Requires no soil, no farmland, no chemicals, and no permission from any corporation, government agency, or patent holder. The 828 million people on this planet currently suffering from protein-calorie malnutrition do not need a new pharmaceutical intervention. They do not need a branded supplement with a marketing budget. They need a bucket of water and a plant that has been feeding civilizations for 2,000 years. The most nutritious organism on the planet is not extinct. It is not locked behind a patent wall. It is floating on a pond near your house right now, waiting to be harvested instead of poisoned. Thanks for watching. Click here to check out another video. Make sure to hit subscribe.